Good evening, friends. So today we'll be discussing about the reaction mechanism involving the reaction of alkenes with the Br2 in the presence of ccl4. So one point you must understand that ccl4 is a solvent and it doesn't play any role in the reaction mechanism, and Br2 is going to be our main element which is going to play a major role in the reaction mechanism. So let us dive deep into the topic. So first let me take an alkene CH2 and let me react this with bromine Br2 in the presence of ccl4. So one must understand that Br2 exists in this form, and you can notice that bromine has 8 valence electrons, 1 2 3 4 5 6 and 7 and 8, and even for this bromine, and out of which 2 of them are shared with the other bromine atom, and even this bromine has 8 valence electrons, 1 2 3 4 5 6 and 7 and 8. So now the bromine atom is completely neutral, it is not having any charge. Now when it comes in contact with the pi bond of this CH2, what happens is, when it comes in contact with this pi bond, what happens? That's going to be the major question. So let us discuss about that. So pi bonds, as you all know, is very reactive and has a tendency to remove the electrons very easily. Since bromine is already having an octet and it doesn't want to change its position or state, but still this pi bonds having the 2 electrons have a new home inside this Br, since Br is having an empty orbital, because of which these pi electrons can occupy this empty orbital. So now let us draw some more neatly. CH2, and so I already told that the electrons in the pi bonds will have a new home, that is the the empty orbital of Br. So Br instantly breaks into 2. So this one gets a negative charge, this one gets a positive charge, because it breaks heterolytically, not homolytically. We already saw that homolytical division will result in the production of free radicals, but here we can see that the bromine atoms, that Br and Br, break heterolytically, because of which they acquire a negative and positive charge respectively. Now one of the Br plus, which is very important to us, so this is called Bromonium ion, and if you take Br minus, and this we may not be using immediately, but yes, we may be using them in the near future within the reaction mechanism. Now this bromonium is, what does this bromonium ion do? So that's a major question. So let us come back to the structure once again. So now let me draw the structure again. We have our CH2, we have our bromine ion, bromonium ion, and now when it comes in contact with this CH2, see, one of these pi electrons and it contains electrons which is belonging to both CH2, this CH2 as well as this CH2. So what happens is, one of the electron, okay, it comes, that is one of the pi bond, shifts one of the single, as the this 2 electrons shifts from there to bromine. So it looks just like this: CH2, single bond CH2, and the bromine will be here, and it will be getting its electron. Now you can see that already we have told that Br plus, okay, Br plus was electron deficient. It acted as a electrophile. Electrophile means electron deficient. Now you can see that it is electrons are fulfilled by the electron that is coming from this pi bond, that is from the single bond of that pi bond. Now what happens? You can see that since there is a electron shift towards the bromine, there will be a partial positive charge that is created over here, and the bromine gets neutralized, that is all of its octet gets completed here. 1 2, because 1 2 3 4 5 6 7 and 8. Now as you already know that this carbocation, okay, which looks like carbocation, now it has a, so we already learned that carbocation is nothing but a carbon which has 6 electrons and it has an empty orbital. So because of that, what happens? Carbocation empty orbitals lies over here, and it lies very close to this electrons of valence electrons of Br. Now what happens is very amazing, because already we know that Br is highly stable because it is in octet stage. This carbon, okay, is also having an octet. See, 2, 4, 5, 6, 7 and 8. So it's an octet stage. But if you see this carbon, it is not in octet stage. So what happens is, since the bromine is very close to the empty orbital of that carbocation, what happens is the electron that is in the valence shell of bromine goes to the empty orbital of the carbocation. So it may not be intuitive, because we may think that the distance between them is so great, but you should understand that the distance between the bromine and the empty orbital is very, very small. It's like nanometers. So it's less than a nanometer. So we should understand that the electron from the valence electron from the bromine atom, okay, it goes to the empty orbital of the carbocation. So what happens? So as we know that when electron leaves, there will be a partial positive charge in bromine, and this carbon will attain its complete octet. So how many electrons will go? I told already that 2 electrons will go. So this carbon will be able to obtain the octet configuration. So let us see the diagram how it looks. CH2, bromine, 1, 2, 3, 4, 5, 6, 7, 8, and this belongs to CH2 also. So now this is the stage that is obtained. So you can see that this is nothing but a cyclic carbocation, because even though you may think that it is a completely neutral, some partial positive charge remains in this, and this also gets some partial positive charge. Okay, so this is the stage now. Now what happens next? Now you may ask a question: what about the Br minus we initially had separated from the reaction? So now this Br minus comes into picture. As I already told you, they will be coming the later part of the reaction mechanism. Now what does this Br minus do? So let us see that some more detail. Now what does this Br minus do? So it comes over here, Br minus comes over this part, and it comes and attacks this carbon. So I already told that there was a partial positive charge in this carbon, and there was also some positive charge in this bromine as well. So what happens is, as soon as this bromine comes and attacks this carbon, then the electron necessity of this particular carbon will be fulfilled by this bromine, by the incoming bromine. So what happens? The partial positive charge slowly recedes, right? So what happens is, the bond over here, this bond, it slowly shifts towards bromine. So it looks something like this: CH2, CH2, Br. And what happens? I told, so this positive charge slowly recedes. So this bromine which is attached over here, its electronegativity also, its positive charge also recedes. So it attains complete octet like this. Now what happens is that it comes back to its original position. So this structure again can be read on something like this: CH2, CH2, Br, Br. So what did we see in this reaction, the mechanism? We saw that once and bromine in the presence of ccl4, that is the solvent here, which is not playing any role in the reaction mechanism, but it's used as a solvent, and so when the bromine attacks this alkene, you can see there is an anti-addition of bromine. Anti refers to the addition. What you may ask, what is an anti-addition? So anti-addition refers to the addition of the bromine atoms or any other atom across the carbon-carbon bond in the opposite directions. So it should be like this. Okay, so this is called anti-addition, and we also observe this in the case of this particular alkene, which is ethene. Now let me solve some more questions for you. So let us take one question, and the question is like this: cis but 2ene, okay, in the presence of Br2, the presence of ccl4. So how do we solve this question? So let me tell you one of the easiest tricks to solve one of such questions. So always prefer to draw a diagram like this. So we already knew that cis but2ene, it looks something like this. But refers to 4 carbon atoms, and but2ene is this one. So it is a cis, okay, right? So let us draw some more neatly. So it looks something like this, right? Carbon, carbon, and here you get your CH3, right? So this is our CH3, and this is H, this is H. So I already told that cis refers to, anti refers to the addition of the carbon or any other atom on opposite side of the double bond, but here we are adding on the same side, so we refer to as cis addition. So here we saw that it is cis but2ene. Now when we react this with Br2 in the presence of ccl4, what happens? So now let us see. So I will be teaching you guys one of the direct method, is called DM method, to solve such questions, which is very useful in exams. So you need not always follow the reaction mechanism to solve such questions, because it may consume a lot of time. So let me see, teach you guys a direct method. So can I write this particular compound which I gave previously, that is this compound, like this, carbon, carbon, right? So I have broken the pi bond, so it looks something like this, yes or no? CH3 and CH3 and hydrogen, yes or no? So now you can see that there is empty space over here, which you may think will be occupied by bromine. But remember, we already told that in case of Br2CCl4, there will be addition in the anti position. That is, there will be anti addition, not syn addition. So we must understand that we should not add Br over here. We must add in the anti position. So what can we do? So let me teach you an easy trick. So what do we do is simple. So here we have got the cis compound. So whenever you find some empty space over here in the in this position, and you need to do anti addition, like which we require here. So what shall we do is we should directly add bromine on the empty space. So let me draw. We shall directly add bromine here, but remember, we need to rotate this particular compound, okay, in the opposite direction. So let me rotate this particular compound and show you guys. So it looks, after rotation, it looks something like this, right? So here you will have the H, here you will have bromine, here you will have bromine. I told you to rotate only the lowermost part, this part, not the entire thing, only the lowermost part, and you get CH3 here, and here you can see hydrogen, here you can see hydrogen. So you can see CH3. So you can see that we have successfully added bromine in the anti position, right? So this is the thing. So let me repeat. So whenever you want to do anti addition, and you see space in the cis position, what do? You just simply add them, in cis, that is in simply do syn addition. We may write it like simply do syn addition and then rotate the lower half, right? So this is the thing. So now you may ask, so what shall we do in case of when we need to do syn syn addition? We need to do syn addition. Simple. So wherever you find the space, for example here you're finding space, you just add them directly over here and you'll get your answer. In case of anti, you need to add them and rotate this particular part, and in case of syn, you just need to add them directly over the syn, that is the empty space. Okay, so now let me talk some more things about this particular answer what we got here. So let me draw the answer some more neatly. So you can see we got the answer as this: Br, H, CH3, Br, and hydrogen. Now let us talk about the chirality of this particular compound, of this carbon. You can see that this is a chiral carbon, and you can also see that this is also a chiral carbon, yes or no? Because all the four groups that are attached on all the sides of the carbon valency, you can see they are different. So we can see that there are two chiral carbons over here, and you can also get if you put a mirror over here, you can also get a mirror image. How does that mirror image look like? Let me draw here. So this will be a compound. So if you put a mirror over here, you will get a mirror image like this. So sorry. So you will get a mirror image like this. So the Br and CH3 will switch their positions. It will look like this: CH3 Br and Br CH3. So we can clearly say that this particular compound is optically optically active, and it is also having an enantiomer. So from this answer we concluded that this particular compound, whatever we got as the answer, so it is optically active as well as having an enantiomer. So they may ask like these questions in exam to identify the compound, okay, which is having an optical activity. They may give the reaction and ask you to determine whether this shows optical activity or not, or whether it has some enantiomer, okay, with respect to it or not. So that's all for this video. So let us see in some other video in future. Thank you. Thanks for watching.